Welcome, class. This is your first distance learning lesson. Today you will need your notebook and your basic antiderivative rules. If you need a reminder of what your antiderivative rules look like, they should be from your notes, and they should look something like this. Basic antiderivative rules. You have a warm-up on the board. Go ahead and pause the video and work out the warm-up problems. By this point, you should have paused the video to try the warm-up problems, and we're going to go over them together. This first question is an antiderivative. I'm asking for the integral of dt over t plus 2. So this problem is a basic u substitution problem. T plus 2 is going to serve as my inside function. So u equals t plus 2. When I'm doing a u substitution, I find u, my inside, then I take the derivative of u, which is called du. Du is just going to equal the derivative of t plus 2. Well, the derivative of t is dt, and the derivative of 2 is 0. Okay, so u is going to be t plus 2. And then du is going to be this part here, dt. So what I get is this integral is equal to the integral of dt, well dt, that's just du, over t plus 2, well t plus 2, that's just u. So I've got the integral of du over u. Now I'm going to look at my rules, and I'm going to recall that the integral of du over u, oh, that's right there, is equal to the natural log of u plus c. Now this only works if it's u to the first power down in the denominator. If it were u to any other power, we would be using the power rule. But this is the natural log, so this is ln, the absolute value of u, plus c. And then there's one more step. This is ln, the absolute value of t plus 2, plus c. There's number 1. For number 2, we started with y prime. Y prime equals x minus 4, then y equals what? So here, I want to find an antiderivative. I'm starting with my first derivative, y prime. I'm trying to find y. Okay, well, the antiderivative of y prime is just y equals the antiderivative of x. Well, this is x to the first. I'm going to be using the power rule here. So this is going to be x to the second power over 2. Minus, well, this is the antiderivative of 4. The antiderivative of a number, remember, is number variable plus c. So the antiderivative of 4 is 4x plus c. Now, I want to talk just a little bit more about this answer. I want to think about what the function y equals x squared over 2 minus 4x plus c looks like, because that's going to help us with our lesson today. So thinking about this function, we've got a y equals, and I've got x squared over 2 minus 4x plus c. Well, this is a quadratic function. It's a parabola, and because this x squared term is positive, it's going to be facing up. So I've got some parabola that faces up. If I were to draw that on a coordinate plane, I would want to know where to put the parabola. And so plus c comes into play here. This parabola is going to have its vertex at x equals positive 4. Let's think about why that is. Y prime, remember, is the derivative. If I take y prime and make it equal 0, that's going to be the max or min of my parabola. So remember, y prime is x minus 4. If I say x minus 4 equals 0, then x would equal 4, and that's going to be the max or min of my parabola. This parabola is facing up, so it's going to be a minimum. But what does the plus c do? Well, the plus c shifts this parabola up or down. So the truth is, I don't know exactly where this parabola is going to be. I could have a parabola like this, and like this, like this. They would all be centered at 4. But I don't know where the y-intercept is. So I would be shifting this parabola up or down depending on what c is. So that brings us to our topic of the day. And the lesson that we are going to be learning about today is solving a differential equation by separation of variables. So our main topic for this lesson is solving a differential equation by separation of variables. For my second period class, this is going to be a review. For my fifth period class, this is going to be a new topic. So when we're thinking about when we're thinking about differential equations, the first question should be, what is a differential equation? A differential equation is, as its name suggests, an equation. And a differential equation can involve derivatives, independent variables, and dependent variables. So a differential equation is going to be an equation involving x, y, y prime, sometimes y double prime, and sometimes higher order derivatives. We're typically going to be focusing on ones that just have x, y, and y prime. Although in this case, y prime, we're going to be calling dy dx. Y prime and dy dx, those are the same thing. For our purposes, a differential equation is going to be an equation that is dy dx equals some expression that has both x's and y's. So it's a differential equation because I've got a first derivative of y and x. We're dependent, where we have a equation that involves both independent and dependent variables and derivatives. Now, my topic wasn't just differential equations, it is solving differential equations. So that brings me to the point, what does it mean to solve a differential equation? Solving a differential equation would mean finding, if I started with dy dx equals, solving would be finding what y equals. So I start with dy dx, the derivative of y, and I have to go backwards to find y. And my goal is to get y as a function of x, meaning what y equals can only have x's in it. This should sound familiar. Number 2 of our warm-up, we started with y prime, which remember, y prime and dy dx are the same thing, and we went backwards to y. Here's the thing though, in my warm-up, I had a plus c. This would be considered a general solution because I have plus c. In this lesson, we're going to be learning how to find y and then how to solve for c, which is called the particular solution. So c is going to be some number, and I'm going to have to figure out what that number is. So the next thing that I want to do is I want to learn how to solve a differential equation by separation of variables. Number 2 in your warm-up was fairly straightforward because it was y prime equals x minus 4. Notice that there's only x here, but in a differential equation, we're going to have x's and y's. So that's going to complicate things just a little bit. And there are 2 steps to solving a differential equation by separation of variables. There are 2 steps. The first step is to separate variables. And the second step is to integrate. So this process, solving a differential equation, goes separate and integrate. What does this mean? Separate the variables means I need to use multiplication and division to get all the x's on one side and y's on the other. Integrate simply means to take the antiderivative of both sides. This probably seems a little vague at this point, but I think it'll be more clear once we see an example. Example 1. Consider the differential equation dy dx equals negative x y squared over 2. Let y equals f of x be the particular solution to the differential equation with the initial condition f of negative 1 equals 2. So what I've got here is a differential equation. dy dx, notice it's dy dx equals, just like we talked about before. And then I've got this fraction that has both x's and y's. My variables are y and x. Y is dependent and x is independent. The particular solution is y equals f of x. This is a free response question, and I'm just going to be doing part C here. Part C asks me to find the particular solution y equals f of x to the given differential equation with the initial condition f of negative 1 equals 2. So what they're telling me to do is I've started with dy dx, I've got a dy dx equals, and I'm trying to find what y equals. Here's how we're going to do this. I'm going to start by rewriting my differential equation dy dx equals negative x y squared over 2. And I am going to do my steps. I'm going to separate and I am going to integrate. When I am separating, if I've got dy dx equals to a fraction, a great way to start is by cross multiplying. I am going to cross multiply to start the process of separation. I'm always going to remember to put the d whatever at the back of the equation. Okay, so this gives me dy times 2, so that's 2 times dy, equals negative x y squared times dx. So now it's not a fraction anymore. It's going to be a little bit easier to work with. On the left-hand side of the equal sign, I've got 2 and dy. Y is my variable, and I don't see any x's, so the left side is good. But let's look at the right side. I've got negative x y squared dx. Uh-oh. This is not separated yet because there's still a y with the x's. So what I have to do now is move this y squared to the left side of the equation, and I'm going to do that by division. Whatever I do to one side, I do to the other. Divide by y squared, divide by y squared. The y squareds cancel from the right side. These y's do not cancel though. So what I've got now is 2 dy over y squared equals negative x dx. All right, there are no x's over here. There are no y's over here. This is separated. So step 1, separate variables. Check, I've done that. The next step is to integrate. Whatever I do to one side of the equation, I am going to do to the other. I am going to take antiderivatives of both sides of this equation. All right, the left-hand side here, y is in the denominator. So that might make you think of our warm-up where we had to use a natural log, but this actually is not the natural log rule. this is going to be a power rule question. The reason this is a power rule is because y is being squared here. Y squared, though, is in the denominator. That means I'm going to rewrite this to make it more friendly to use my power rule. This is the same thing as the integral of 2y to the negative 2 dy, which equals the integral of negative x dx. Okay, I'm going to bring this 2 out to the front. So I've got, actually, no, I'm not going to do that. I'm going to use my rules here. Now, I know it says y instead of u, but that's okay. Negative 2 is my exponent, so I'm going to add 1 to that using my power rule here. I'm going to take the antiderivative. I'm going to drop the integral symbol because I'm doing the antiderivative. 2 tags along. Y to the power of, what is negative 2 plus 1? Negative 2 plus 1, that's negative 1 over negative 1. Now, there is a plus c, and that's very important. However, what's going to happen is I'm going to be adding, let's just add plus c, equals the integral of negative x dx. Okay, well, this is negative x to the first power. Again, this is a power rule here, so I'm going to have negative x to the 1 plus 1, that's 2, over 2, plus c. These c's are constants. This could be like 10 and this could be like 17. I would want to combine them into both sides. This is one constant. This is a second constant. They're not necessarily the same. So if I subtract this constant from both sides, what's going to wind up here is these two combine. So I never had to add this constant here in the first place. I can just add plus c to the right side and be done with it. Okay, we're almost done here. So remember, my goal was to find a y equals. My goal was to find a y equals. But y is not by itself. So what I'm going to have to do is I'm going to have to solve for y. The first thing I'm going to do is I'm going to simplify this. This becomes negative 2. So this is negative 2y to the negative 1 power, which equals negative x squared over 2 plus c. I'm going to divide both sides by negative 2. So this is y to the negative 1 equals negative x squared over 2 plus c over negative 2. But this isn't y equals, this is y to the negative 1. Gosh, what is y to the negative 1? I can rewrite that as 1 over y. So this is 1 over y equals negative x squared over 2 plus c over negative 2. Now, since y is in the denominator here, I want y equals, not 1 over y equals. I could just take the reciprocal here. So I'm going to take the reciprocal of both sides of this equation. I'm going to take the reciprocal of both sides of this equation, coming up top, zooming out so you can see. 1 over y, that's going to become y over 1, equals whatever I do to one side, do to the other, negative 2 over negative x squared over 2 plus c. And this is y over 1. I can just call that y equals. Well, great, I've got y equals. That was the goal of the question. But it has to be y as a function of x. The problem is there's an x and there's a c. So what I need to do is I need to use my initial condition. F of negative 1 equals 2. Negative 1 is x, 2 is y. I'm going to substitute in so that I can solve for c. So y is going to become 2, x is going to be negative 1. I'm going to have 2 equals negative 2 over negative, and then x is negative 1 squared over 2 plus c. Negative 1 squared. Negative 1 squared, I'm going to forget that. This part's 1. This part is 1. So it's negative 1. So I've got 2 equals negative 2 over. This guy all is negative half plus c. Multiplying through by my denominator here, I'm going to have 2. Negative half plus c equals negative 2. I'm going to distribute, so I'm going to have negative 1 plus 2c equals negative 2. Solving for c, add 1 to both sides. 2c equals negative 1, and c equals negative half. Now that I know c equals negative half, I'm going to take c and plug it back into my y equals equation here, and I'm going to get a final answer of y equals negative 2 over negative x squared over 2 minus 1/2. And that is my final answer. Y'all have an assignment that is posted on the Google Classroom. Please check in with me during lecture on Wednesday and come for tutoring anytime Monday through Friday 9 to 10 a.m. or Thursday 7 to 9 p.m. Thank you guys for watching.